You know that feeling, right? That big wave of nostalgia for classic RC cars.
Oh, yeah.
Especially if you ever had a Tamiya Frog back in the 80s. Great kit, the 58041.
Absolutely. And then the excitement when the re-release, the 58354, came out in 2005.
Yeah. But that excitement often turned into something else, didn't it? Frustration, maybe?
For a lot of people, yes.
Yeah.
Because it had this, well, this pretty glaring issue.
Yeah, front wheel thing.
Exactly. The whole front wheel, the axle shaft, even the nylock nut just suddenly decided to part company with the rest of the car.
Right in the middle of a good run, usually, like
Yeah.
mid-jump, everything's looking great, and then, whoops, where'd my wheel go?
It became a pretty well-documented problem.
Yeah, that's why we're diving deep today. Using your sources, we want to really perform a forensic analysis on this.
Get right down to the nuts and bolts, so to speak.
Not just how it happens, but the real why. And then, crucially, give you the solid solutions to make that classic buggy reliable again.
Okay, so let's break it down. The anatomy of the failure.
Where does it actually go wrong?
The absolute core of the problem is that press-fit connection. You've got the spline steel axle shaft, that's part MD7.
Okay, steel. Hard.
Right. And it's pressed directly into the steering knuckle, or upright, which is part K8. And that upright is cast aluminum.
Ah, softer aluminum. Steel splines pressed into aluminum. I can already see where this might go.
Precisely. It's a material mismatch under stress. Think about off-road driving.
Yeah, it's not smooth sailing.
Not at all. You have torsional loads twisting from the steering. You get lateral impacts when cornering hard.
And big tensile loads when landing jumps, pulling forces.
Exactly. All these dynamic forces are constantly working on that connection. Over time, those harder steel splines basically act like little cutters.
Chewing away at the aluminum?
They wear away the softer aluminum inside the upright's hole. The hole gets slightly bigger, the grip gets weaker,
Until it's just not holding anymore?
and the whole axle assembly pulls free.
Okay, that makes mechanical sense. But here's the kicker, the real puzzle. Why the 2005 re-release? Why did it fail so much when the original 1983 Frog seemed, well, pretty solid in this area?
That is the crucial question. And the answer seems to lie in subtle but really significant differences between the vintage parts and the re-release ones.
Material changes, manufacturing differences.
Both, likely. Sources suggest the vintage 83 uprights probably had a rougher surface finish from the casting process.
Giving the steel splines more to bite into, better friction.
That's the idea. Now compare that to the 2005 re-release uprights.
Yeah.
People describe them as smoother and more shiny.
Less grip right from the start.
Potentially, yes. And there's also suggestion they might have lower wear resistance, essentially being a slightly softer or less durable aluminum alloy compared to the original.
So a weaker connection inherently, just based on the parts themselves.
It seems that way.
Yeah.
And this material weakness, this potential softness, it gets compounded by another factor.
Which is
The whole ORV chassis front suspension design. It's known for being, well, a bit loose and wobbly.
yeah, those kingpin step screws can have some play. Annoying slop.
And that slop contributes significantly to bump steer. That's where the wheels steer themselves a bit, unpredictably, as the suspension compresses and rebounds.
Ah, so that's putting weird extra forces on the axle connection, twisting and pulling it in ways it wasn't designed for.
Exactly. Abnormal loads hammering on that already questionable press fit. The tougher 1983 material could likely handle that extra stress.
But the smoother, possibly softer 2005 material just gives up.
That seems to be the consensus.
Yeah.
It's a great example of how seemingly small changes in materials or finish can really cascade into a reliability nightmare.
Wow. Okay, so we understand the why. Now, how do we fix it? If you've got a re-release Frog or Brat with this issue, what are the options? Two main routes you mentioned.
That's right. There's the quick, cheap sort of field repair, and then the more permanent engineered solution.
Let's start with the quick one, the epoxy fix.
Yes. High-strength epoxy bonding. You want something specifically good for metal, like a metal-filled two-part epoxy. JB Weld Original is often mentioned, something with high tensile strength.
And the key here, like any gluing job, must be the prep work, right?
Absolutely non-negotiable. You have to be meticulous. First, degrease everything: the axle splines, the inside of the hole, and the upright. Get rid of any oil or dirt.
Makes sense. Clean surfaces.
Then, you need to key the surfaces. Take a small file, or even carefully use a Dremel bit to rough up the surfaces slightly. Create a crosshatch pattern.
Ah, creating more surface area for the epoxy to grab onto.
Exactly. Maximizes the bond strength. Then mix the two-part epoxy thoroughly. Apply it carefully to both the axle and inside the hole. Insert the axle.
And then, wait, Patience is key here.
Crucial. Let it cure fully. We're
Mhm.
talking a full 24 hours typically for maximum strength. Don't rush it or it'll just fail again.
Okay, so that's the JB Weld approach. Cheaper, doable. But what about the best fix? The permanent one.
For that, you're looking at the Tamiya Hornet upright conversion. This is the gold standard fix because it completely eliminates the problematic press fit.
How does it do that?
You basically swap out the Frog's aluminum uprights, K8, with the plastic uprights from the Tamiya Hornet. Those use a conventional design with the axle spinning inside ball bearings housed within the upright.
Ah, so the axle isn't pressed in anymore. It's properly supported by bearings. Much better. What parts do you need?
You need the Hornet C-Parts tree, which has the uprights. The part number is 1-900-5148, or the older 900-5069, and bearings, of course.
Is it a straight swap, or are there modifications needed?
There's one critical modification: the steering linkage. The tie rod mounting point on the Hornet upright is lower than on the Frog's aluminum one.
So if you just bolt it up, you'll mess up the steering geometry, cause bump steer.
Precisely. You'll actually worsen the bump steer. The fix is to adjust how the tie rods connect to the servo saver.
How do you do that?
You attach one tie rod to the top of the servo saver horn and the other tie rod to the underside of the horn. This changes the angle.
Levels them out, basically, to match the lower point on the Hornet uprights.
You got it. It corrects the angle and minimizes bump steer for proper handling. It's also a good time to upgrade to a Tamiya High Torque Servo Saver, part 50473, and make new adjustable tie rods using M3 threaded rod and 5mm ball connectors.
Right, might as well make the whole system better while you're in there. That sounds like a really robust, permanent solution.
It absolutely is. It fundamentally fixes the design flaw.
Now, this axle issue, is it purely a Frog problem, or does it affect other related Tamiya buggies, the ORV family?
Good question. It definitely affects the re-released Subaru BRAT, Kit 58384.
Because it uses the same chassis
And the same aluminum front uprights, part K8. So the BRAT suffers the exact same failure mode and benefits from the exact same fix as epoxy or the Hornet conversion.
Okay, Frog and BRAT are susceptible. What about the monster truck versions on that chassis? The Blackfoot and the Monster Beetle re-releases.
They dodged this particular bullet.
Oh, why is that?
The re-released Blackfoot 58633 and Monster Beetle 58618 use different front uprights. They use plastic ones, similar in concept to the Hornets, though maybe not identical, but crucially, not the aluminum press fit design.
So no axle pullout issue for the monster trucks from this specific cause.
Correct. Now, that's not to say their front ends are perfect. They have their own issues, often even more pronounced bump steer because of the bigger tires and suspension geometry, and sometimes problems with cracking rear arm mounts. But that's a whole different deep dive.
Gotcha. Different problems for a different day. So let's just wrap this up for everyone listening.
Okay.
Basically, if you've got a re-released Tamiya Frog or Subaru BRAT, that annoying front axle failure is real. It boils down to a combination of likely changes in the aluminum upright material properties in the re-release,
Making it less able to securely hold that press-fit steel axle.
combined with the inherent slop and bump steer tendencies of the ORV chassis front suspension, putting extra stress on it.
That's the core of it.
But the good news is, you now know what's going on and you have clear paths to a solution.
Right. You can go for the careful, meticulous, high-strength epoxy fix, making sure you do the prep work right and give it full cure time.
Or, for the ultimate permanent fix, you can perform the Tamiya Hornet upright conversion, swapping to plastic uprights with proper bearings and adjusting the steering linkage.
Which totally eliminates the original failure point.
Exactly. By tackling this specific Achilles heel, you really can turn your classic Tamiya buggy, the Frog or the BRAT, into a much more durable, reliable machine.
Ready to handle the off-road bashing it was kind of always meant for, without that fear of a wheel making a sudden escape.
So the final thought for you is, now that you understand the problem and the solutions, what approach will you take with your classic Tamiya? Will you carefully epoxy or go for the full conversion? The choice is yours, and hopefully a more reliable run awaits.